Let's take a look at number 5. So to solve this system of equations using the elimination method, we need to look to see if we can somehow find opposite terms so that when we add them together, we get that sum of 0. So what would be nice is if we could get these wide terms to cancel out. What we can do is we can multiply the top equation by 2 to get 4x plus 10y is equal to negative 30. Bring this equation over. Negative 12x minus 10y is equal to 70. When we add now, the y terms will add to 0 or be eliminated. And what we have left is negative 8x is equal to 40. Divide both sides by negative 8, and we get x is equal to negative 5. Now, we're going to take one of the original equations. Let's take the top equation, 2x plus 5y is equal to negative 15. Substitute the negative 5 in for x, so 2 times negative 5 plus 5y is equal to negative 15. Negative 10 plus 5y is equal to negative 15. Add 10 to both sides, and we get 5y is equal to negative 5. Divide both sides by 5, and y is equal to negative 1. So the solution as an ordered pair is negative 5, comma negative 1. Okay, let's do the check for this one. So 2x plus 5y is equal to negative 15. 2 times negative 5 plus 5 times negative 1 is that equal to negative 15. Negative 10 minus 5 is that equal to negative 15. Negative 15 equals negative 15, check. And then negative 12x minus 10y equals 70. Negative 12 times negative 5 minus 10 times negative 1 is that equal to 70. Negative 12 times negative 5 is 60. Negative 10 times negative 1 plus 10 is that equal to 70, and both sides are equal to 70, so it checks. For number 6, we're going to solve the word problem by setting up a system of equations. Remember, we're going to first read and understand the problem, decide what it is that we are trying to find, make a let statement to define the variables, set up a system of equations using the words and the information in the problem, solve the system, make sure our answer is reasonable and makes sense, and then we're going to go back and answer the question with a sentence. So we have a sporting goods store that sells 12 baseball gloves, some of which are right-handed and some of which are left-handed. Right-handed gloves cost $45 each, and left-handed gloves cost $52 each. The total revenue from the gloves sold was $561. How many of each type was sold? All right, so we know there were 12 baseball gloves sold, some right-handed, some left-handed. Right-hand gloves are $45. Left-handed gloves are $52. The total from the gloves sold is $561. Okay, let's let X equal the number of right-handed gloves sold. And let Y equal the number of left-handed gloves sold. Okay. We know that there were a total of 12 gloves sold, some left-handed, some right-handed. So our first equation is x plus y is equal to 12. We know that the revenue totaled $561. Right-handed gloves were $45 each, left-handed gloves $52 each. So our next equation is 45x plus 52y is equal to 561. Okay, now we can choose which method we want to use to solve, whether it is substitution or elimination. Let's use elimination. I'm going to multiply this top equation by negative 45 so that I can eliminate the x terms. Multiply everything through by negative 45, we get negative 45x minus 45y equals negative 45 times 12 is negative 540, and then 45x plus 52y is equal to 561. Now when we add the equations, we get the x terms to be eliminated. These add to 0, and we get 7y equals 21. Divide both sides by 7, and y is equal to 3. Now to solve for x, let's just go back to x plus y equals 12. So x plus 3 is equal to 12. Subtract 3 from both sides, and we get x is equal to 9. So to answer the question, the store sold 9 right-handed gloves and 3 left-handed gloves. Let's finish up this last question. So we have students and adults purchased tickets for a recent basketball playoff game. All tickets were sold at the ticket booth. Season passes, discounts, etc. were not allowed. Student tickets cost $5 each, adult tickets cost $10 each, and a total of $4,500 was collected and 700 tickets were sold. Okay, so we're going to write a system of equations that can be used to find the number of student tickets S and the number of adult tickets A that were sold at the playoff game. And we're going to solve the system to find the number of tickets sold to each group. Okay, so let S equal number of student tickets let A equal number of adult tickets. Remember, if you're given the variables to use in the problem, make sure you use those given variables. Okay, what's the system going to look like? So in the words, we know that student tickets cost $5, adult tickets cost $10, a total of $4,500 was collected. So we can do 5S plus 10A is equal to 4,500. We also know that a total of 700 tickets were sold, so S plus A is equal to 700. Now we can use either elimination or substitution to solve the problem. Let's use substitution for this one since we used elimination in the last one. So I'm going to change this equation here. I'm going to subtract S from both sides to get A is equal to 700 minus S. Now we're going to substitute 700 minus S in for A in this equation. So 5S plus 10 times 700 minus S is equal to 4,500. Distribute the 10, and we get 5s plus 7,000 minus 10s is equal to 4,500. 5s minus 10s is negative 5s plus 7,000 is equal to 4,500. And now we're going to subtract 7,000 from both sides. I'm going to take it up here now. And we get negative 5s is equal to negative 2,500. Divide both sides by negative 5, and we get s is equal to 500. That's the number of student tickets that were sold. And since s plus a is equal to 700, 500 plus a is equal to 700. Subtract 500 from both sides, and we get a is equal to 200, which is the number of adult tickets sold. So there were 500 student tickets sold and 200 adult tickets. And you can write that in a sentence. For the last part, assuming that the number of students and adults attending would not change, how much more money could have been collected at the playoff game if both students and adults were charged the same price of $10 per ticket? Okay, so if all the tickets were $10 per ticket, then the total collected would have been 700 times the 10, which would have been $7,000. $7,000 is how much more than the 4,500 that was collected, and that's 2,500. So if both students and adults were charged the same amount of money, they could have collected an extra $2,500. Okay, thank you for tuning in to the SOS video explaining the solutions to all the problems on this extra practice. I hope you found it helpful, and good luck on your assessment.